Okay, I again start from our lecture. Entire screen. Okay. So as we said, today we'll cover some subsections from chapter 4, that is 4.3.1, that is about the IP datagram header format. Then 4.3.2, a process called fragmentation. And then 4.3.4, that is 4.3.3 is not necessary. So 4.3.4, that is network address translation. And we'll start chapter 5 if we have time today. If not, then we'll start chapter 5, that is routing algorithms, in the next class. Okay, now let us first start with the format of an IP packet or IP datagram. So how many rows in the header field can you see? Only in the header field. কতগুলো রো আছে? 1
4টা স্যার
2 3 sorry 1 2 3 4 5 6. There are 7 rows, but not in the header, right? In total there are 7 rows. The lowest row represents the data. So network layer carries what? নেটওয়ার্ক লেয়ারের মধ্যে কি থাকে? নেটওয়ার্ক লেয়ার প্যাকেটের মধ্যে কি থাকে বলো? Segment, right? TCP or UDP segment. So for a network layer datagram or packet, data is what? A TCP segment or a UDP segment, right? So payload or data in a packet contains variable length, typically a TCP or UDP segment. This can be ICMP also when we use ping. So the lowest box actually represents data, right? So the rest of the rows represent what? Header fields. But out of those header fields, there is one row, that is the 6th row, that is called options. That means it contains some fields that is optional. Okay, but there are 5 rows that must be in a IP datagram. So how many rows minimum have to be in IP datagram header? 5. Each row contains 32 bits. See, 32 bits. How many bytes? 4 bytes, right? So each row contains 4 bytes. So how many bytes will be in an IP header in minimum? Minimum number of bytes in an IP header কত হবে?
স্যার 4
4 into 5, 20 bytes. দেখো প্রত্যেকটা রো হচ্ছে 4 bytes, রাইট? প্রত্যেকটা রো 4 bytes না? আমার স্ক্রিন দেখা যাচ্ছে না?
জি স্যার দেখা যাচ্ছে
হ্যাঁ, প্রত্যেকটা রো 4 bytes, এটা কি বুঝতে পারছো? উপরে দেখো 32 বিটস আছে। 32 বিটস মানে কত বাইট?
স্যার 4 বাইট
4 bytes. Simple. 8 bits, 1 byte. That means 4 bytes. So each row is equal to 4 bytes. So how many rows other than option in the header? How many rows? 1, 2, 3, 4, then 5. So 5 into 4, how many bytes? 20 bytes, right? এটা কি বোঝা যাচ্ছে না?
জি স্যার।
একটু রেসপন্স করবা, তাহলে তো আমি বুঝতে পারি না যে তোমরা কি আমার সাথে আছো কি নাই। ওকে, নাও what are the fields in IP datagram? One by one. Let us see one by one. First one, version. IP protocol version number. That is version 4, version 6, right? So there is version 4. Then second one, header length. Because there is an optional field, So minimum header length is 20 bytes, but it can be up to 24 bytes, right? So header length is specified. Next one, length. Length means what? Length means total datagram length. That means including header and payload or data. Data or payload, same thing. Then maximum length of a packet can be 64K bytes, 64 kilobytes. It can be maximum, but typically it's a 1500 bytes or less. Typically, it depends on the underlying data link layer protocol. We'll see shortly. Then in the this another field called type of service. What is type of service? By using type of service, actually we can differentiate different type of data. For example, video data, audio data, right? So this is indicated by type of service, and based on type of service, there are different types of services provided. For example, differentiated services. There is another one called ECN, but don't worry about type of service field. We need other fields mainly. So time to live, TTL. TTL represents how much time a packet will live in the network. That is remaining maximum hops. So whenever a router receives a packet, router decreases the TTL value by 1. So for example, if the value is 20, the receiving router will change the value to what? 19. Then the second one will change the value to 18. So in this way, if the TTL value is 0, then the receiving router will discard the packet. That is the idea. So that a packet cannot travel in a network for an indefinite amount of time. অনেক সময় দেখা যায় যে কিছু প্যাকেট নেটওয়ার্কে ঘুরতেছে for different reasons. It can happen. তাহলে সেই প্যাকেটগুলো কি ক্যাপাসিটি ওয়েস্টেজ করবে. So we must remove the packets in a certain way. So TTL is the way by which we can discard packets from a network. Those are traveling indefinite times or indefinite ways. Okay. Then there is another field called upper layer. Upper layer means what? Which layer is the upper layer of network layer? Bolo network layer upore layer ta ki? What is the network layer? On top of
Transport layer.
transport layer. Very good. Transport layer. So upper layer protocol indicates whether the protocol is TCP or UDP. আমরা জানি যে transport layer there are two types of protocols, right? So is it TCP or UDP? Also there can be ICMP. We use ping. So ICMP also can be in the upper layer protocol field. So this field actually indicates what is the upper layer protocol. Next one, very important. 3 fields in the second row. That is the 16-bit identifier. There are some flags and there is a fragment offset. All these 3 fields in the second row is used for fragmentation or reassembly. We'll see shortly how these fields are used in the fragmentation process. Then there is a checksum. Why checksum is used? For error detection. In every layer, checksum is used for error detection. And then definitely there are 2 fields called source IP address and destination IP address. Both are 32 bits. And these 2 addresses actually indicates the source host and the destination host. And there are some optional fields if needed, but this is not mandatory. For example, timestamp, record route taken, there can be some fields. So this is the overview of an IP datagram format. So we must understand the important fields of the header. Any question? Okay, so remember that the 16-bit identifier, flags and fragment offset. কয়টা field এখানে? Second row তে কয়টা field বলো?
তিনটা স্যার।
তিনটা, এই তিনটা একটু মাথায় রাখবা, একটু পরে আমাদের এটা কাজে লাগবে। These three fields are used for fragmentation and reassembly. Okay, so overhead means, actually header means overhead, right? We saw in chapter 1. So we already saw in TCP minimum header is 20 bytes, right? We already covered chapter 3. And also in chapter 4, we see here minimum header in an IP packet is also 20 bytes. So if we consider an application data with transport header and network header, then we can say, okay, the application layer overhead for TCP IP, for any application, plus there is 20 bytes of header in TCP and there is 20 bytes of header in IP. So if in anywhere there is no information about the header, you can safely assume that the header is in network layer, the header is how much? 20 bytes, right? কোনো কোশ্চেনে যদি কোথাও বলা না থাকে তোমরা ধরে নিবা হেডার ইজ 20 bytes. সবাই ক্লিয়ার কিনা? Can we move?
Yes, sir.
Okay. So another very important concept now, network address translation. Okay. So as Nafiul said, now we need to know why this network address translation is needed. Actually, it comes from the idea of private IP and public IP. Actually, previously all IP was public IP. Okay. So what was the problem with public IP? It was exhausted. It was being exhausted very fast. So what happens? Whenever a new organization needs some block, the IP must be assigned so that they can set up the network and participate in the internet. So to preserve the public IP addresses, because public IP address is limited, to preserve the public IP addresses, every class, as you said in the last lecture, right? Class A, class B, class C. So let us review class A, class B, class C. How we can identify? আমরা কিভাবে আইডেন্টিফাই করতে পারি ক্লাস A, class B, class C? Anyone?
স্যার ফার্স্টের ডিজিট গুলা দেখে স্যার, যেমন আমরা
First
10
octet.
বলতে জি স্যার।
Right. First 8 bits. Doesn't matter. Less 24 bits doesn't matter. First 8 bits. First octet's value actually indicates its class. Now you can ask me why the classes are important. Because there are organizations who has largest network, like Microsoft, like Google, like Facebook. So they need a huge number of hosts in a particular network. So they will use class A. Then there are medium category networks. They can use class B, because in class B, we have 16 bits per host, 2 to the power 16 minus 2 hosts per network. And for smaller networks, the number of possible networks in this category is the largest, right? So network bits 24 and host bit 8. But the first octet indicates the class. Okay. So now IP version 4, তোমরা already জানো যে IP version 6 চলে আসছে, right? IP version 6 চলে আসছে. Why? Because IP version 4 addresses were being exhausted 10-15 years back. তখন থেকেই বোঝা যাচ্ছিল যে এই IP version 4 অ্যাড্রেসটা আসলে খুব দ্রুত শেষ হয়ে যাবে। সো তখন থেকেই তারা around 2000 they started to develop IP version 6, and probably in 2006 IP version 6 was formally introduced in the practical arena. Still there is a very few progress in implementation IP version 6, because there is huge number of setup, huge investment setup in IP version 4. So we don't know how many years we still have to keep up with IP version 4. But at the same time, IP version 6 is getting getting increased day by day. The problem is IP version 4 addresses are being exhausted. So to preserve those addresses, a policy using private IP is introduced. How? In every class, there is a block defined that is not needed for registration. তোমরা জানো পাবলিক আইপি যদি ইউজ করতে হয়, পাবলিক আইপি কিন্তু রেজিস্ট্রেশন করতে হয়, কোন একটা আইএসপির কাছ থেকে পাবলিক আইপি কিনতে হয়। বাট যেটা বললাম যে খুব দ্রুত পাবলিক আইপি শেষ হয়ে যাবে। সো what was the solution? One solution was NAT. Sorry, one solution was private IP. How? In every class, for class A, the block is 10.x.x.x. That means what? That means, okay, let us okay, network address translation. So private IP blocks. Okay, what are the private IP blocks? Class A 10.x.x.x. That means the first, as we know, in class A, the first octet value can be 1 to 126, right? So out of these possible values, only block 10 is preserved for private IP. So যে কেউ যদি ক্লাস এর 10 দিয়ে নেটওয়ার্ক তৈরি করতে চায়, fine. Any number of organizations can use the same block without registration as long as there is no interconnection between them. 1000টা অর্গানাইজেশন যদি 10 ব্লকটা ইউজ করে, 10 ইউজ করে এবং তাদের মধ্যে যদি কোনো কানেক্টিভিটি সরাসরি না থাকে, তাহলে কোনো সমস্যা নাই। তার মানে কি? তার মানে সেম ব্লক ক্যান বি ইউজড বাই any number of organizations. That means what? That means definitely IP address will be preserved, right? So that was the idea. So similarly, for class B, which is 128 to 191. এগুলো কি তোমাদের ল্যাবে বলা হয়েছে?
জি স্যার, আইপি অ্যাড্রেস গুলোর নাম বলা হয়েছে স্যার।
হ্যাঁ হ্যাঁ, মানে ওইটা তো বলা হয়েছে, বাট প্রাইভেট আইপির ব্লকটা নেট যখন করবা তখন বলা হবে, বাট এখানেও আমি কিছুটা বলে দিচ্ছি। সো ইন ক্লাস বি 128 to 191, so there will be the block 172.16.x.x. x.x means anything. So first two octets are specified in this way. So 172.16 to 172.31 in class B is preserved for private IP. That means these blocks cannot be used in the internet, cannot be used by any public network. Okay, this is only reserved for private IP. Anybody can use. Similarly, class C, for class C, that is 192 to 223. We know this block indicates class C. For this block 192.168.x.x. So clear? So if you see 192.168, that is a private IP. So in every class there is a block or blocks defined for private IP. Now, why that is done? As you said, to preserve public IP. So these blocks can be used by any number of organizations in the world, any number of times, no problem. So we can give same block to many organizations for use. But the only problem is, the only rule is, whenever you use private IP, you cannot connect to the internet directly. Got my point? So only limitation, or that is the rule actually, not the limitation that is defined. You can use private IP without registration, but you cannot connect to the internet directly. Otherwise the problem will happen, right? আমার 10 ব্লকটা তো 1000 অর্গানাইজেশন ইউজ করছে, তাহলে সবাই যদি একই নেটওয়ার্কে কানেক্ট হয়, ডুপ্লিকেট হবে না? So that is not possible. So for private IP, ISP, what ISPs do, they actually block this because these are defined. So any ISP router blocks this. So whenever a packet comes from this IP addresses, ISP will block. ISP will not forward to the internet. So using private IP, you cannot browse internet. But if you check your own IP, we all use internet, right? Currently, we are lecturing, participating in the class using internet. But if you check your IP address, most of you will find, maybe all of us will find our IP address in this range. That means private IP. So the question is how we are connecting to the internet. বুঝা যাচ্ছে? Main purpose of NAT. So actually network address translation is a solution so that we can use internet using private IP. Okay, now we need to know how NAT works. The basic is very simple. Since private IP cannot be routed through internet, using private IP I cannot connect to the internet directly. So how NAT works, I will implement NAT in my router, or an organization will implement the NAT in their router, so that whenever a request goes to the internet, the router will change the local private IP to a public IP that we must configure, or we must provide to the router. That can be one single public IP, that can be 10 public IPs. We must run those public IPs from any ISP or of authorized organization, and then we define in our router. So what router simply will do, whenever from any private IP anyone browses internet, before forwarding the packet, they just change the private IP to a given public IP. So that is the idea. Any question? Okay, now let us again see how NAT works. So this is the idea. On the right side, this is a local network, home network. So the network address is 10.0.0/24. What type of network, what type of IP? Private or public? This one? 10.0.0.
Private IP.
Right? Already we saw that in class A. The only block that is private is 10. If it is 11, that is public. If it is 13, that is public. Only 10 is private. So the right side, we implemented a network with private IP, but now we want our users, our customers, to be able to browse the internet. So what we'll do, we'll configure NAT in the router. Sorry. And then the router will do one thing. All datagrams leaving the local network will be assigned a public IP. That is, we call NAT IP address. 138.76.29.7. There is a one single public IP that is also assigned in the router interface, but that will work as a public IP so that router can translate all private IPs to that public IP. So that is the idea. So when router forwards with that IP, all internet ISP routers will process the packet because the source is now public. It is no more private. Let us see how this happens. Okay, advantage, disadvantage later. First, see a more detailed example. Okay, so for example, from 10.0.0.1, I am a user. I am using this PC with 10.0.0.1 IP address. Then I am browsing internet. What will happen? Packets will be generated where source will be 10.0.0.1. There will be a port number assigned by the operating system 3345, and then the destination will be the address of the server. For example, facebook.com, google.com. So the address of the server in this example is 128.119.40.1186. Is this public or private? 128.119.40.186. That is public IP or private IP?
স্যার পাবলিক।
পাবলিক আইপি। এটা কোন ক্লাস? 128
ক্লাস
কোন
বি।
ক্লাস? ভেরি গুড,
ক্লাস
ক্লাস
বি।
বি। সো ক্লাস বি তে প্রাইভেট আইপি কোনটা?
স্যার 172।
172 শুধু বললে হবে না, 172.15 পর্যন্ত
0.16
কিন্তু, রাইট, 0.16 থেকে 0.31। দ্যাট মিনস 0.16 এর আগের গুলোও পাবলিক, 31 এর পরের গুলোও পাবলিক। ওকে, সো this is a public IP. That means there is a server in the internet. So a user is browsing to the internet using private IP. Now what happens? See, if there is no NAT defined in the router, if router forwards the same packet to the ISP service provider will discard the packet simply. But instead, if we use NAT, the router will use a table. You see, দেখতে পাচ্ছ এখানে net translation table, right? So there will be a table. This is not forwarding table. This is a separate table maintained by router if we implement NAT. তোমরা ল্যাবে যখন করবা তখন দেখবা যে শো আইপি নেট ট্রান্সলেশনস একটা কমান্ড আছে, সেই কমান্ডের আউটপুটটা আসলে এখানে দেখাবে। তো তোমরা যদি ম্যাচ করো দেখবা যে এরকমই দেখতে পাবা। ওকে, একটু ডিফারেন্ট হবে, বাট আইডিয়া ইজ সেম. There are two parts. One is LAN side address, one is WAN side address. What is the LAN side address? Anyone? What should be the LAN side address? Related to private IP, right? LAN means local network. So this is the private IP. And WAN means internet, outside. This is the public IP. So what will happen? Router will change. What is the change here? From packet step 1 to step 2. প্যাকেটে কোথায় চেঞ্জ হয়েছে বলো? দেখো, জাস্ট কম্পেয়ার
সোর্স
উইথ দ্য
চেঞ্জ হয়েছে স্যার।
এক্স্যাক্টলি, সোর্স চেঞ্জ। আরেকটা স্পেসিফিক কি বলা যায়? প্রাইভেট আইপি is changed to a public IP, right? So
জি স্যার।
10.0.0.1 is changed to 138.76.29.7. Now, first question, where the router gets this public IP? Right? এই পাবলিক আইপিটা কোথা থেকে পাবে? আমাদেরকে এটা অ্যাসাইন করে দিতে হবে। আমরা কোথা থেকে পাবো? We have to collect from ISPs, right? Or authorized agents. 1 public IP, 10 public IP, just you have to pay the rent. You have to get the public IPs, then you will configure in the NAT, then router will know, okay, this is the public IP. I have to convert all private IPs to this. Okay, so now what happens? With the private to public, also see the port number is changed. For the host, it was 3345. Now it is 5001. So my question is, why this port is changed? It could have been the same, right? 3345. Problem কি ছিল? Got the point? So why router changes port number? Got my question? Don't worry about the answer. Questionটা বুঝা গেছে কিনা? যে সোর্সের পোর্টটা কেন চেঞ্জ করা হয়েছে? আচ্ছা, just keep in your, just remember it. We'll see the answer. Okay, now see what is the change in the destination. Is there any change in the destination field? No change, right? No change. So destination is not changed. Why? Because destination is public IP. So NAT never changes the public IP. NAT only changes the private to public, and when the feedback come back, then it changes from public to private to forward to that particular host. Okay, how it happens? Now this packet will be forwarded to through the ISP, through the service providers to the server. Then server will send, right? Server will send a reply. What is the change between step 2 and step 3? Is there any change? চেঞ্জ হয়েছে? স্টেপ 2, স্টেপ 3, yes or no? Any
Yes,
change?
sir.
Sir,
Yes, sir. What
change
is the
তো
change? What is the change?
So destination
Just,
from 130.
that means just source and destination is reverse, right?
Yes, sir.
জাস্ট সোর্সটা ডেস্টিনেশনে চলে আসছে, স্বাভাবিক। এ থেকে বি তে যখন একটা মেসেজ যাবে আর বি যখন রিপ্লাই পাঠাবে কি হবে? জাস্ট উল্টিয়ে যাবে, রাইট? সো সোর্স এন্ড ডেস্টিনেশন জাস্ট রিভার্স, নাথিং এলস। সো স্টেপ 2, এটা কোথায় গেছে বলো তো? এটা কিন্তু তোমাদের বুঝতে হবে, এখানে ডায়াগ্রামে নাই। এটা কোথায় গেছে এই প্যাকেটটা? স্টেপ 2 এর প্যাকেটটা ইন্টারনেটে যে সার্ভারের কাছে আমরা পাঠাতে চাচ্ছি, সার্ভারের কাছে গেছে, রাইট? ঠিক কি না?
Yes, sir.
হ্যাঁ, না বুঝলে কিন্তু কোশ্চেন করতে হবে। আমি আরো বেশি ইন্টারাকশন এক্সপেক্ট করতেছি, কারণ এই এই কনসেপ্টটা যদি তোমরা বুঝতে পারো খুব সিম্পল, না বুঝতে পারলে একটু কমপ্লেক্সই মনে হবে, বাট ব্যাপারটা আসলে সিম্পল। সো স্টেপ 2 অ্যাকচুয়ালি indicates the packet is going to the server, for example google.com, yahoo.com, facebook, those are the publicly available server. Now server will send a reply, just source and destination reverse, and then what happens? See, from step 3 to step 4, is there any guess? What should be changed from step 3 to step 4? Now see,
sir IP
now
address.
that means the destination IP is router's public IP now, but to forward the packet to 10.0.0.1, again router needs to convert this to the host's private IP, right? See what happens. Is it clear? So now two things will be clear. Number one, why router maintained a NAT translation table? Number one, because otherwise how the router will know that which internal host actually requested? So which internal host the packet should be forwarded now? Router কোত্থেকে পাবে? From the NAT translation table. Clear কিনা? So router goes to NAT translation table. Router sees that, okay, this 138.76.29.7.5001, this packet actually was from 10.0.0.1 and port number 3345. Now I have to convert this to this. See, the destination now was from ISP, it was public IP. Now it is the host private IP. So what effectively what happens? A host using a private IP is able to browse internet, right? যদি নেট না থাকে এটা কি পসিবল? নো। Why not
না স্যার,
possible?
তাহলে তো সম্ভব হবে না।
আইএসপি সেটা ব্লক করে দিবে, আইএসপি সেটা ডিসকার্ড করে দিবে। বাট যেহেতু আমার রাউটার এটাকে পাবলিকে কনভার্ট করছে, আইএসপি সেটাকে প্রসেস করছে, যখন কাম ব্যাক করছে তখন আমার রাউটার আবার সেটাকে আমার পার্টিকুলার হোস্টের কাছে ব্যাক করে দিচ্ছে। সো ক্লিয়ার কিনা এক্সাম্পল? So there are 4 steps and every time actually router translates. So that is why it is called network address translation. Any question? Okay, now let us see some of the advantages of NAT. Okay, first one, we can browse internet using private IP. How? We need at least one public IP address, but without public IP it will not work. But using one public IP, you can actually create more than 60,000 connections for using one public IP. So if you use more public IPs, that is better. Also, you can change anytime, you can change the internal addressing mechanism without informing the ISP, because router is in the middle. So there is no direct connection between the ISP side and my local network side. That is in one sense advantage. So anybody from the internet cannot directly access to my network. That is also another advantage, that is security. So there are some advantages, and this is how this works. And now the answer of the question. Why router changes the source port number? It changes the source IP address because that was private. It must convert to public. Fine. But why it needs to change 3345 to 5001? Any idea? Okay, now suppose assume the second host, that is 10.0.0.2, also browses the same website. হতে পারে না আমার ইন্টারনাল নেটওয়ার্ক থেকে facebook.com এ কতজন ঢুকতেছে, তাই না? বা google.com এ কতজন ঢুকতেছে? It can be more than one, not more than one. It can be hundreds of users. So just consider two users browsing internet with one public IP. Then what will happen? বলো কি হবে? ধরো 10 আরেকটা এন্ট্রি তৈরি হবে না 10.0.0.1 0.2 and for the simplicity assume the second host also uses 3345. সিনারিওটা কি বোঝা যাচ্ছে? সেকেন্ড যে হোস্ট সেও 3345 ইউজ, দুইটা ডিফারেন্ট হোস্ট সেম পোর্ট নাম্বার ইউজ করতে পারে, নো প্রবলেম। বাট then what will happen when server replies to both the hosts? So when router replies, if we use this port number, sources port number, then what will happen? There will be two entry with the same port number, right? So is there any problem when server returns the reply? প্রবলেম হবে কি মনে হয়? যখন দুটা বা তিনটা বা চারটা হোস্ট সেম পোর্ট নাম্বার ইউজ করে পাঠাবে, আমার কাছে একটাই পাবলিক আইপি আছে, তার মানে পোর্ট নাম্বারটা যদি আমরা সেম রাখি তাহলে এখানে কি হবে? সেম হবে না?
জি স্যার, আমার তো মনে হয় স্যার প্রাইভেসি ব্রেক হবে।
না, privacy is not a problem. Problem is how router will decide which packet to forward to which internal host, right? যে তার তো পাবলিক আইপিও একই, পোর্ট নাম্বারও একই, কিন্তু দুইটা ডাটা তো আলাদা। একজন হয়তো এই পেজটা ব্রাউজ করছে, আরেকজন অন্য পেজ ব্রাউজ, দুইটা ডাটা আলাদা হবে না? কিন্তু যখন 3 নাম্বার স্টেপে আমরা কি দেখলাম, যখন ব্যাক করে তখন রাউটার কিন্তু এই এন্ট্রিটার সাথে ম্যাচ করে, রাইট? সো এটা যখন ম্যাচ করবে তখন তো সে দুইটা একই পাবে। এখানে ওয়ান সাইডের দুইটা এন্ট্রি একই হবে, 138 76 2907 138, কারণ we have only one public IP. So if we use the same port number 3345 there will be two entries in the one side with the same public IP and same port number. Then how will decide? রাউটার কিভাবে ডিসাইড করবে যে কোন প্যাকেটটা কাকে ফরওয়ার্ড করবে? তার মানে we must differentiate in the one side, right? If we have multiple IP, no problem, IP will be different. But if we have same IP, then how can we differentiate? So that is the reason. The answer is using port number. So this port number is not the normal port number. This port number is generated by the router. Why? To trace each connection. So যদি 10.0.0.1 থেকে পাঠানো হয় তাহলে 50001 ইউজ করবে সে, 10.0.0.2 থেকে পাঠানো হলে সে 5002 ইউজ করবে। এরকম যতগুলো ইউজার সাইমালটেনিয়াসলি অ্যাক্সেস করবে সবার জন্য সে শুধু পোর্ট নাম্বারটা আলাদা করবে, পাবলিক আইপিটা আলাদা করতে পারবে না। ওয়াই? বিকজ পাবলিক আইপি ইজ গিভেন এ সিঙ্গেল পাবলিক আইপি। So that is why we use, or router uses port number in NAT, and that is called port address translation, PAT. Any question?
আচ্ছা স্যার, আমার প্রাইভেট আইপিটা তো আসলে সবার আলাদা থাকতেছে না।
Definitely.
আচ্ছা, আমার প্রাইভেট আইপি পুরো আলাদা আলাদা ভাবে দিতে হবে।
রাইট, তোমার কোশ্চেনটা ঠিক আছে। এখানে যদি আমার 10.0.0.2 হয় এবং পোর্ট নাম্বার যদি 3346 হয়, নো প্রবলেম।
জি স্যার, 45 আমরা প্রাইভেট আইপি আলাদাই থাকতেছে, সেক্ষেত্রে তো আমি
প্রাইভেট আইপি আলাদা, কিন্তু ওয়ান সাইডের আইপি কি হবে সেটা বলো।
ওয়েবসাইটে তো
কিন্তু
সেম আইপি থাকতেছে, কিন্তু আমার প্রাইভেট
আমরা
আইপি ইনফরমেশন থাকতেছে না আলাদা।
প্রাইভেট আইপি আলাদা থাকছে, কিন্তু তুমি মনে করো তুমি রাউটার, তুমি এখন নিজেকে রাউটারের জায়গায় চিন্তা করো। তোমার কাছে তোমার কাছে এখানে দুইটা ডিফারেন্ট এন্ট্রি ল্যান্ড সাইডে, বাট ওয়ান সাইডে দুইটা সেম, রাইট?
জি স্যার।
আচ্ছা, এখন প্যাকেটগুলো ব্যাক করলো, দুইটা প্যাকেটই সে ব্যাক করলো, তুমি রাউটার, তুমি কাকে কোনটা দিবা?
স্যার আমার কাছে তো প্রাইভেট আইপি আলাদা আলাদা ইনফরমেশন আছে না।
আলাদা আছে, বাট তুমি কিসের বেসিসে দিবা? মনে করো যে দুইটা প্যাকেট আসলো, এখানে দুইটা প্যাকেটেরই তো ডেস্টিনেশন দেখো, এই যে স্টেপ 3 ডেস্টিনেশন একই না? ডেস্টিনেশন পোর্ট নাম্বার দুইটা প্যাকেটেরই একই। এখানে কিন্তু একটা প্যাকেট দেখাচ্ছি আমরা, ধরো দুইটা আসছে। এখন যাওয়ার সময় তো ঠিক ছিল, যাওয়ার সময় আমি প্যাকেটটাকে সুন্দর মতোই আমি ইয়ে করছি, সমস্যা হয়নি, আমার তো প্রাইভেট আইপি আলাদা। কিন্তু যখন রাউটার যখন ব্যাক করবে তখন কি হবে বলো? তখন রাউটার কিভাবে ডিসাইড করবে? ডিসাইড করতে পারবে কিনা? নো ওয়ে, নো ওয়ে। কারণ সে তো ল্যান্ডসাইড আলাদা ভালো কথা, যখন প্যাকেট দুইটা আসবে, প্যাকেট দুইটার মধ্যে, আচ্ছা আমাকে বলো যে ওই প্যাকেট দুইটার স্টেপ 3 একই হবে না ডিফারেন্ট হবে? কোনো চেঞ্জ হবে কিনা?
না স্যার, কিন্তু স্যার আমার কি জানি প্রাইভেট আইপি গুলা তো কিভাবে ডিফারেন্সিয়েট করতেছি আমি?
এই দ্যাট ইজ দ্য প্রবলেম। প্রবলেম তো হচ্ছে যখন স্টেপ 3 থেকে 4 এ যাবা, দেখো 3 থেকে 4 এ কি হচ্ছে, পার্টিকুলার হোস্টের কাছে ফরওয়ার্ড করছে, কিভাবে করবে সে? এখন খেয়াল করো, যদি এখানে হোস্ট 1 এর জন্য যদি 5001 দেওয়া হয়, আর হোস্ট 2 এর জন্য যদি 5002 দেওয়া হয়, তাহলে কি এটা সলভ হয়? এটা আগে চিন্তা করো, প্রবলেমটা সলভ হয় কিনা, দুটো আলাদা হয় কিনা?
জি স্যার।
হ্যাঁ, সো দ্যাট ইজ দ্য সলিউশন। এখন ল্যানের পোর্ট ইয়া আলাদা, সমস্যা নাই, আইপি আলাদা, বাট উইদাউট মেকিং ইট ডিফারেন্ট ইন দ্য ওয়ান পার্ট অলসো, ইটস নট পসিবল। তুমি যদি ওয়ান পার্টে আটটা আইপিও একই, পোর্টও একই, কোনো ওয়ে নাই ডিফারেন্সিয়েট করা, বিকজ অনলি router will forward based on destination IP and destination port number. If destination IP and port number is same, then router cannot decide on local IP. So that's why router actually changes the source IP to its own, sorry, source IP, not source IP, source port number with its own port number. But একটা জিনিস এখানে খেয়াল করো, এই পোর্ট নাম্বারটা কিন্তু কোনো কিছুতে পার্টিসিপেট করছে না। হোস্ট সেন্ডস পোর্ট টু পোর্ট নাম্বার 80। পোর্ট নাম্বার 80 মানে কি? পোর্ট নাম্বার 80 মানে কি? এনিওয়ান?
স্যার ব্রাউজার?
না, পোর্ট নাম্বার 80 মিন্স ওয়েব সার্ভার। ব্রাউজার তো মানে তার এখানে 3345। So see, from 3345, this is source port number, 80 is the destination port number. In step 4, source port number is 80, destination port number is 3345, right? So there is no trace of 5001 or 5002 used. So from end to end, that is working fine. This is transparent to the user. I am browsing internet, no problem. This is transparent to the user. But the problem is, we have to router has to use its own port number to keep trace. That is the only reason why router uses port number, and this is called PAT. So you will see NAT PAT, network address translation oblique port address translation. Why port address translation? Because port number can be used so that using a single public IP, we can send many translations. We can create many simultaneous connections. Clear? But NAT is actually controversial. NAT has many drawbacks because this is an ad hoc solution to preserve public IP, but this has several disadvantages or drawbacks or controversies. It violates the end-to-end argument. Normally, what happens? We assume from source end system to destination end system, as we saw in an example, right, in chapter 1, IP will not change. So source IP and destination IP will never change in the middle. That was the idea. But in this case, we see the server doesn't see the source IP, and the host actually sees server IP, but the IP is changed in the middle. Okay. And there is another problem, that is, from internet, it is not possible to identify a host using a IP address. So there are some disadvantages of NAT. Okay. Okay, now next topic is IP fragmentation reassembly. Okay, what is fragmentation? Making fragments, right? Now the first question, why we need fragmentation? Because every network layer, okay, by the by, network layer is implemented in software or hardware according to layering concept?
So software.
Software, definitely software. So network has no way to connect to the hardware, right? So that's why network is called media independent. Now what happens when a network layer, when a router wants to forward a packet to a link, that particular link has maybe wireless, maybe wired, has different capabilities. So every link has a value called MTU, that is maximum transfer unit. That means every link says, okay, I cannot carry more than this amount of bytes in a single packet. Why? Because that depends on particular protocol, that depends on the link characteristics, that depends on the hardware, that depends on the signaling. So all these are taken care by data link layer, right? Amra layering amra pore aschi na je data link layer is the only layer that works at the hardware and software both. So data link layer e ashle pore ashole jana jay je ekta linker capacity koto. That capacity is MTU. But as we said, network layer is independent of media. So network layer cannot, it is not possible for network layer to know the maximum transfer unit of data link layer. So what happens when a particular router forwards a packet and a link actually supports that size, no problem. But maybe in the next link, next data link layer does not support the packet size. Maybe MTU is lower, less than the original packet. Then what will happen? Then fragmentation happens. Now how fragmentation happens? Then the router which will forward the packet will create different parts of the packet called fragments according to the capacity of the link. So the capacity is MTU. So according to the original packet size, it creates different smaller packets called fragments. It can create 3, 4, 5 depending on number of data bytes it needs to carry. So for example, the original packet is fragmented into 3 different packets. The red part is the data in the diagram of each packet. The red part is the data, represents the data or payload, and the blue part represents the header. Okay, so when it creates fragments, each fragment is actually a different packet. Every fragment will have a different header. Then all these fragments will travel through the network as a single packet, and then finally definitely it will reach the destination because all the fragments will have the same destination. So the destination will finally reassemble the original packet. So this is the idea of fragmentation. Any question? Is it clear? Okay, so whenever a host creates a packet, there can be 10, 20 links in the middle, and it is not possible to know the MTU of each link separately. So that's why fragmentation happens, and this fragmentation and reassembly happens in the network layer. Now the question is how this process will work. As we said in the header, there are 3 fields. One is ID, one is flag, and one is fragment offset. Now let us see how this happens. So for example, there is an original packet, length is 4000 bytes, and ID is, for example, X, then flag 0 and offset 0. Okay, why flag is used? Flag is used to indicate when fragmentation happens, every flag value will be 1. 1 means more fragments coming. So for example, if there are 3 fragments, then first 2 fragments sender will set flag equals to 1. That means this is not the last fragment, more fragments coming. So the receiver will wait for the last fragment before starting reassembly, right? In this example, see, the receiving host will see, okay, I have received fragment 1, flag is 1. That means I cannot start reassemble because there are more fragments coming. So another fragment is received, again flag is 1, another fragment is received, now flag is 0. So flag 0 means this is the last fragment, and now the receiver can start reassembly. So this is the use of flag. Now what happens? There can be out of order fragments, right? Fragment 3 comes first, fragment 2 comes later. This can happen because every fragment is a packet and travel independent of each other. So packet 3 can come first, packet 2 can come later. How you can sort, how you can reorder, number 1. Number 2, there can be some fragments missing, like packets can be lost, fragments can be lost. So how to detect whether there is a loss of fragment? So for both these reasons, the offset is used. How offset is used? For every fragment created by the sender, initially offset will be 0. Offset indicates number of bytes data already sent. So for the first packet, first fragment, offset will be 0, definitely. Now, if there is no fragmentation, what is the value of flag and offset? ধরো কোনো একটা প্যাকেট ফ্র্যাগমেন্ট হয়নি, তাহলে ফ্ল্যাগের ভ্যালু কত হবে, অফসেটের ভ্যালু কত হবে, কে বলতে পারবে?
স্যার ফ্ল্যাগ তো 0ই থাকবে,
রাইট, বিকজ ফ্র্যাগমেন্টই হয় নাই, নো নিড টু মেক ইট 1, রাইট? আচ্ছা, অফসেট, it will be also 0, because if a packet is fragmented, the first fragment will have offset 0. If the packet is not fragmented, then definitely the offset will be 0, because no data already sent. So flag 0 means last fragment, offset 0 means what? First fragment, right? So if last fragment is first fragment, then fragmentation কি হইছে? যদি আমি বলি যে ফ্ল্যাগও 0, অফসেটও 0, তাহলে আমরা কি বলতে পারি? No fragmentation is done. বলতে পারি কিনা?
জি স্যার, ফ্র্যাগমেন্টেশনের প্রয়োজন হয়নি।
প্রয়োজন হয়নি, exactly. So this is one point you have to keep in mind. If flag equals to 0, that means this is the last fragment. If fragment happens, still. If offset equals to 0, this is the first fragment. If flag equals to 0, offset equals to 0, this means this is the last fragment, this is the first fragment. So last fragment is যদি first fragment হয়, তার মানে কি fragmentation হয়নি? So that's why দেখো, for the initial original packet, this is the information of the original packet where length is 4000, ID is X, flag is 0, offset is 0. Now MTU is 1500 bytes. That means the next link says I cannot carry more than 1500 bytes data in a single packet. So what we need to do? We must fragment. How? This is the example how it can be done. Okay, before that, 4000 bytes length, that means what is the data? How many bytes data out payload? How many bytes header? বলো, হেডার কত বাইট? কি বলছিলাম যে কোশ্চেনে কোথাও যদি বলা না থাকে হেডার কত বাইট ধরে নিব? 20 ধরে নিব আমরা। বলা থাকলেও 20, আর যদি বলা না থাকে তাইলেও 20, যদি বলা থাকে 24 তাহলে 24, বাট যদি বলা না থাকে 20. MTU is the maximum, is the total length. MTU is the total length of each packet. So 1500 also contains header, 4000 also contains header. So what we will do, we first need to know how many bytes of data must be carried by fragments. So we'll deduct the header from the data. So from 4000, just make it, okay, let me show you the calculations. Okay, so this is the example. Now let me show the calculation. So example original packet length equals to 4000 bytes, right? And MTU is given what? 1500 bytes. That means if we say original packet length is 4000 bytes, then definitely data or payload will be 4000 minus 20, 3980 bytes. Okay, let us do in this way. Okay, now MTU is 1500 bytes. That means we can say data or payload per fragment, right? Per fragment equals to what? 1500 minus 20 equals to 1480 bytes. Is it clear? So we can, right? It should be clear. So original packet contains 3980 bytes of data, and every individual packet in that link can carry 1500 bytes. That means it can carry 1480 bytes of data. Now we can calculate in this way. 3980 bytes need to be transferred. So if we can see this way. So in the first packet we can carry 1480 bytes, right? So not packet, is fragment number 1. I can write like this. Now you can, okay, so you subtract this, and then you will get 2500 bytes remaining, right? Again you subtract further 1480 for the second fragment, because this should be the second one. So this is fragment. Just I am showing you how you should think. This is easier to understand, so that's why I am showing in this way. So this is fragment number 2. So in fragment 2 we have sent another 1480 bytes, right? So remaining 1020. So this is definitely less than 1480. So we don't need any more fragments, right? So this should be fragment number 3. Is it clear? So if remaining bytes more than 1480, then definitely we would have to send another packet, right? Since 1020 remaining number of bytes less than 1480, so this is the last fragment. Now by this way we know, okay, how we can send 3980 bytes in how many fragments. You can take a note: fragment 1, fragment 2, fragment 3, and then now you can see the example again. Is it clear? The calculation clear? Okay, now let us come back to here. So one large datagram becomes several smaller datagrams. I have already shown you how we have calculated. So the first fragment will have length 1500. Length means including header. So 1480 plus 20. So it is 1500. ID will be, okay, for the ID, remember, for the ID part of each fragment, that will be the original packet's ID. Why ID is needed? Multiple packets may be fragmented, right? So if receiver receives fragments of multiple packets, receiver needs to identify which fragment represents which packet. So each fragment of the original packet will carry the ID of the original packet. So two packets will have different IDs. All the fragments will carry different IDs according to the original packet. That's why, see, the all fragments has ID X. Now, for the first two fragments, flag equals to 1 because this is not the last fragment. For the final one, flag equals to 0. Now, final point, offset. Okay, how offset is calculated? See, first offset is 0. That means you can think about how many bytes already sent before. So for the first fragment, this should be 0. Starting byte, this should be 0. For the second fragment, offset should be number of bytes sent in the first fragment. For the third, number of bytes sent for the first and second. So every time offset can be calculated by summation of previously transmitted data, and theoretically it is divided by 8. Divided by 8. Actually it should be 1480, right? খেয়াল করো এখানে 185 আছে 370 আছে, এটা আসলে 1480 হওয়ার কথা, রাইট? সো আমরা যদি এখন আবার এখানে যাই, fragment 1, now flag will be 1. why? কেন flag 1 হবে বলো?
স্যার এটা এখনো বাকি আছে এর জন্য,
রাইট, আরো বাকি আছে, মোর ফ্র্যাগমেন্টস কামিং। এখানে ফ্ল্যাগের মধ্যে অনেক জায়গায় দেখবা যে ফ্ল্যাগের মধ্যে এখানে এরকম দেখবা মোর ফ্র্যাগমেন্টস, অর্থাৎ অ্যাকচুয়ালি দেয়ার ইজ এ সেট অফ বিটস, দেয়ার আর ফ্ল্যাগস, আমরা এখানে ফ্ল্যাগ বলছি বাট দেয়ার আর ফ্ল্যাগস, সেট অফ বিটস, তার মধ্যে মোর ফ্র্যাগমেন্টসটা আমরা ইউজ করছি। সো মোর ফ্র্যাগমেন্টস ইজ ওয়ান সিঙ্গেল বিট। ইফ ইট ইজ 1, দ্যাট মিন্স মোর ফ্র্যাগমেন্টস আর কামিং। ইফ ইট ইজ 0, that means no more fragments are coming. That means that is the last fragment. So flag bolo ba more fragment bolo, eta first এর জন্য 1 হবে, and then offset will be 0. Sorry, 0. Then for the second fragment, এখানে আমরা এক্সাম্পলের মতো লেন্থটাও আমরা বলতে পারি যে length equals to 1500. That means including header. Okay, then for the second one, now for the second one, length will be same, flag will be still 1 because there are remaining number of bytes, but offset will be now data sent in the first fragment divided by 8. Now why it is divided by 8? The only reason is accommodate larger values in the same number of bits. There is no other reason. বুঝতে পারছো? এটা 1480 ফার্স্ট এটাতে পাঠানো হয়েছে, সেটাই আসলে অফসেট, বাট থিওরিটিক্যালি ইট ইজ ডিভাইডেড বাই 8। তো আমরা যখন কোনো একটা ভ্যালুকে 8 দিয়ে ভাগ করি তখন 8 গুণ কমে যায়, তার মানে আমরা 8 গুণ বড় ভ্যালু ওই রেঞ্জে রাখতে পারি। দ্যাট ইজ দ্য অনলি রিজন। সো 480 ডিভাইডেড বাই 8 মিন্স কত আসে? দ্যাট ইজ অ্যাকচুয়ালি 185। সিমিলারলি দ্য লাস্ট ওয়ান, নাও লেন্থ উইল বি হোয়াট? কে বলতে পারবে? What will be the length of fragment 3? 1020 plus 40, right? Plus 20, right? So 1040.
হেড সহ স্যার,
Right, header shoho. So 1040. Then flag will be now 0 because this is the last fragment. Offset will be you can think like this: 1480 plus 1480 divided by 2. Okay, that means number of bytes sent in the fragments before. So for the fragment 3, the last two fragments will be fragment 1 and fragment 2. So 1418 fragment 1, 1418 fragment 2, it will be always summation of the previous fragments data and then total divided by 2. So if it is 185, then actually this will be 185 2. So this will be 3870. So this is how fragmentation is done. Is it
Sir,
clear?
divided by 8 হবে না?
Kunta?
Sir, 1480 plus 1480 divided by 2 হবে না? Sorry, sir, 8 হবে না?
Oh, okay. Thank you. Definitely divided by 8. Okay. So if, for example, it's a different question. If I say, okay, now assume original packet is 5000 bytes and MTU is 1200. If I say this, then you have to calculate using according to that given information. Any question? Okay, so I think it should be clear. See, we have used those three fields in the second row, that is the ID and flag and offset, to implement a mechanism called fragmentation and reassembly. Okay, so we have covered network address translation, and then we have covered fragmentation. That is end of section 4.3. Now, this is already, we have already discussed network layer functions, forwarding and routing. Now, if we go to control plane, that is chapter 5. Chapter 4 deals with data plane. Data plane means how data packet is forwarded, how fragmentation is done, how network address translation is worked. This is all about based on the data in the packet. But how the packet will be forwarded only based on the destination IP, that is routing. So forwarding can be thought about the data plane, but routing, that is determining the best path for each packet, needs to be thought about control plane. How the control information is implemented, how the routing table is produced. So that actually is chapter 5, but we'll read two sections, two types of algorithms in chapter 5 only. So how this network control plan works, there are two approaches, as we have already discussed in the start of chapter 4 also. Per router control, that is traditional. So if there are 20 routers, for each one you have to configure separately. So that was one way. And then another one is logically centralized control, that is we call software defined networking. So if there are 10 routers or 20 routers or 50 routers, doesn't matter, we'll create a centralized control, and we will include the control information. We'll send the control information to different routers from that centralized control. That is called software defined networking. Now, in any ways, routers need routing protocols. Why? To get the best path, to get good or determine good paths in terms of less time or less distance, okay, from source to destination. Any routing protocol has the same goal. So I think you have already implemented dynamic routing protocol RIP in your network lab, but in the theory we will do some hands-on. We will apply some algorithm, and from scratch until we get the routing table. এটা আমরা থিওরিতে আমরা হাতে কলমে করব। ল্যাবে তোমরা যখন করছো, you just configured router RIP and then you gave network omok, network commutator, and then the routing algorithm worked, and you saw the routing table using show IP route. But in theory, in this class, probably from in the next class, we'll see how a routing table is calculated from scratch. Okay. Now, some terminologies. Today we'll see some terminologies, and then to next class on Wednesday we'll start on some particular algorithm. So, what is path? Path is a sequence of routers packets traverse from source to destination. So, for example, if there are 10 routers, packets might not travel all 10 routers. That packet might travel from A to C to D to E. So, this is called a path. Okay. Now, how you measure the goodness of the path? Is this path better, good, or better? How? In terms of cost. It will have least cost, or it should have minimum number of time fastest, or it will have least congested. Least congested means where it will select the path where jam is minimum. Okay, so for example, if you move from one place to another, you always think about the best path in terms of distance, in terms of time, in terms of expense. Okay, maybe you want to go from Mohammadpur to our permanent campus. Okay, so using public transport, even if you use your private transport, your cycle, your bike, then also you select a path based on the lowest distance, or based on the minimum possible time, or based on the minimum possible expense. So there can be multiple factors to select the goodness of the protocol, but ultimately any routing protocol finds a best path or least cost path based on those factors. And it is also a top 10 networking challenge still with the development of different types of networks. Okay, now how can we see a routing protocol? For example, there is a city, Dhaka city. So there are different places, right? And there are different roads connecting those places. So this is like that. We can think about a graph where there are different nodes. Nodes are actually vertices or routers. And the links, there are some links or edges, and those links might have different costs, like 5, 2, 3. These are all costs. Okay. From where this cost come? This comes from different factors. It can be distance, it can be time, it can be load, congestion, it can be capacity. Okay, so from this we can get a picture like this. So this is, we can call a graph abstraction or a routing problem. Now from any source to any destination, for example from U to Z, you have to apply a routing algorithm to find a shortest path. Okay, so N is set of routers. As you can see, there are 6 routers here, and also there are set of links. That means which routers are connected. For example, there is no link between U to Z, right? So that means what? That means there is no connection between U to Z. There is no direct connection, but you can go from U to Z using some other nodes. So that is a routing problem. And also C, there is a term C, A comma B, that indicates cost of direct link. That means whenever we call, okay, CU comma V, that means this is a direct cost from U to V. When you write CU comma W, that indicates direct cost from U to W. But you can see if you follow U to X, then X to W, then the cost is 4. Then the cost is 4. So that is the lowest cost. So instead of going directly, you can go from U to X to W. Also, you can see, okay, if you go from U to X to Y to W, then cost is further reduced. So this is 3. So you will follow, okay, I will go from U to X to Y to W. So in this way, actually routing algorithm finds the shortest path, and finally it creates the routing algorithm. But any routing algorithm, for any kind of routing algorithm, we can think about how fast do routes change. There is one horizontal line. The faster the routes change, or also there is another parameter called global or decentralized information. So is it required to get the all information by each router, or the local information will be necessary? So based on that, there are two categories. In case of global, all routers have complete topology, link cost information. Those we call link state algorithms. So link state algorithm, in case of link state algorithm, every router must have the entire information. Doesn't matter who are connected, who are not connected. All entire database or topology must be collected by all nodes. Link state. And there is another one called decentralized. In that case, not all nodes need to get the entire database. It can work with partial database, partial topology. These are called distance vector algorithms. Okay, and then how fast do routes change? Based on that, we can categorize you static, as you have already done in the network lab. You have implemented static routes. Static routes means routes change slowly over time because it depends on the administrator. So whenever administrator reconfigures a route, then only the route will change. So that is static. And definitely there are dynamic routes. Dynamic routes means routes change more quickly. Whenever a link is down, routers automatically calculates the new routing table. So it works faster. Okay, so based on that, we can actually divide the routing protocols in two categories. One is link state and one is distance vector. I think we can stop here, and we will start with an example of distance link state routing algorithm that is called Discustrust link state routing algorithm in the next class. So any question? Any question? নাফিউল, সাফাত, হেদায়েত, কোনো কোশ্চেন আছে?
না স্যার, বুঝতে পারছি।
ওকে, ঠিক আছে। তাহলে নেক্সট ক্লাসে হচ্ছে আমরা হ্যান্ডস অন একটা অ্যালগরিদম একেবারে হাতে কলমে করে আমরা দেখব যে ফ্রম স্ক্র্যাচ টু ফাইনাল লেভেল একটা রাউটিং টেবিল কিভাবে আসে। ওকে, আমি একটু রোল কলটা করে নিই। আশিকুল ইসলাম,
Yes, sir.
নার্গিস সুলতানা, ফারজানা,
Yes, sir.
নাহিদুল ইসলাম।
Sir, two present, Nargis Sultana.
ওকে, নাহিদুল ইসলাম আছো। জাকির আল মাহফুজ,
কারেন্ট চলে গেছে স্যার।
আচ্ছা আছে না? আচ্ছা, রবিউল ইসলাম,
প্রেজেন্ট স্যার।
এহসান জাহিন,
স্যার ওর ইলেকট্রিসিটি গেছে।
সাদিয়া ইসলাম,
প্রেজেন্ট স্যার।
আওলাদ হোসেন,
প্রেজেন্ট স্যার।
তাহসিনা ফেরদৌস,
Present, sir.
শাহিদুল ইসলাম,
ইয়েস স্যার।
ইশরাক হাসান, শাহাদাত আলী,
প্রেজেন্ট স্যার।
ফারদিন সালামত,
Yes, sir.
নাজমুস সাকিব,
Yes, sir.
রেজওয়ান চৌধুরী,
প্রেজেন্ট স্যার।
রিফা আব্দুল্লাহ, রাকিবুল ইসলাম
Yes, sir. Sir, রিফা আব্দুল্লাহ ছিল স্যার।
ছিল। আচ্ছা, মাইনুল হাসান,
Yes, sir.
আনিকা রশিদ,
Present, sir.
আরিয়া লাবণ্য,
Yes, sir.
সঞ্জিদা নূর,
Present, sir.
ইমাম হোসেন,
ইয়েস স্যার।
নওশিন নাওয়ার,
Yes, sir.
নাফিউল আছো, ইনামুল,
ইয়েস স্যার।
কাবিল উদ্দিন, মেহেদি হাসান,
Yes, sir.
কাবিল আছে? আচ্ছা, ইন্তেখাব আলম, হামিম আহমেদ,
প্রেজেন্ট স্যার।
ইমন আহমেদ,
Yes, sir.
নাইমুদ্দিন,
Yes, sir.
তৌফিকুর রহমান,
Yes, sir.
ইশতিয়াক ফেরদৌস, Al Imran,
Present, sir.
Sir,
Shihab Jamil,
Present, sir.
Farhana Afroz,
yes, sir.
Ishrat Afrin,
Yes, sir.
Fahim Al Afsaf,
Present, sir.
Saidul Islam,
Yes, sir.
Safat Khan,
Present, sir.
James Hidayat,
Present, sir.
Hidayatur Rahman,
Yes, sir.
Aisha Akhtar,
Yes, sir.
Fauzia Sabrin,
Yes, sir.
Sumaya Hassan,
Yes, sir.
Arman Hussain,
Yes, sir.
Afsana Sharmin,
Yes, sir.
Afia Mausufa,
Yes, sir.
Shariful Islam,
Yes, sir.
Saifullah Riyad.
Yes, sir.
ওকে,
স্যার ইন্তেখাব আলম কি প্রেজেন্ট দেওয়া হয়েছিল?
ইন্তেখাব আলম না আছে।
জি স্যার, আমি স্যার।
আচ্ছা কাবিল উদ্দিন,
স্যার রিফা আব্দুল্লাহ কি দেওয়া হয়েছে?
রিফা আব্দুল্লাহ, তোমার একটু সিরিয়াল নাম্বারটা মনে রাখবা। হ্যাঁ হ্যাঁ, রিফা আব্দুল্লাহ দেওয়া হয়েছে। হ্যাঁ ওকে ওকে, থ্যাংক ইউ। নেক্সট ক্লাসে দেখা হবে ইনশাআল্লাহ। ভালো থেকো সবাই।
ওকে স্যার, আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম।